Hey everybody, welcome to Math Monday. I'm Julie Newberry, 4th grade math teacher here at Cloverleaf. And today I'm going to model how to do partial quotient division, which is much different than the way you and I learned it, which is called the standard algorithm. When we were in school, we learned the basic steps, which was divide, multiply, subtract, bring down. And then we just repeated that over and over, which I know that most of you prefer that method because this is new and very foreign to you. And it was to me too before I started teaching it. But this is actually much easier for the students. Just like we talked about last week when we did partial products, and I showed you how to multiply using the distributive method. This will allow the kids, to make some mistakes. When you do the standard algorithm of division, every single step has to be perfect. There are no room for mistakes, and you have to basically memorize the steps. And again, like we talked about last week, we really want to move away from students just memorizing the steps of how to do a problem and to really have an understanding of why the steps work. It is very difficult for students to memorize steps unless they just are really good at memorization, which most kids are not. So this will provide them a much easier way to solve a division problem. So we're starting with 4,383, and we're going to divide that by 2. Division is, in essence, the same as repeated subtraction, just like multiplication is repeated addition. So what we are attempting to do here is to take the 4,383 and we are going to keep subtracting until we can't make any more groups of 2. This method allows the kids to choose different numbers, and the reason it's called partial quotient is because they are going to be finding a part of the quotient with each step, and then they will combine the partial quotients at the end for their final answer or their final quotient. When we do this method, we want to use numbers that kids can compute mentally, which is called mental math, when they can solve it in their minds and they're using very easy compatible numbers to do their problems. And in the beginning, the students will write out what they're thinking over on the side of the paper. We tend to call that a think bubble in my class. But as they get used to it and as they get better at solving the problems, then this becomes not really important anymore. They don't really have to do that anymore. So we are going to start by thinking of a number that we can multiply by 2 to get as close to 4,000 as possible. So when the students start listing what they're thinking, they know that this number is in the thousands. So again, we try to start with numbers that they can solve mentally. So 2 times 1,000 is 2,000. Which they could start there. We could start with 1,000, subtract 2,000 from this, and keep going. But the higher the number they choose, the better they get at picking where to begin. They're creating less work for themselves. So there's ultimately going to be less steps if we pick a better number to start. So we're just going to double that because 2 times 1,000 is 2,000. 2 times 2,000 is 4,000, which is an excellent place to start considering that we're trying to subtract and get rid of this. So our first partial quotient is going to be 2,000, and 2 times 2,000 is 4,000. And we're going to subtract, and we will have 383. So we're now left with 383. And the kids know that, this is now a number that goes to the hundreds. So we're not going to try to figure out something to multiply by 1,000. So now we can say 2 times 100 is 200. And we can use 100 as our next partial quotient. Or if a student has gotten really good at this, they would be able to tell that 2 times 150 is 300. And this is actually a better number to use because you're going to be getting rid of more of this all in one step. But most of the students at this point would choose 100 because they can all multiply that mentally. So 2 times 100 is 200. We're going to subtract that from our running total. And now we have 183. At this point, the kids usually start trying to think of something that they can multiply by 2 that would get them as close to 18 as possible without going over. Most of them know that that's going to be 9, but we're in the hundreds, so they know to do 90, which is 180. So our next partial quotient is 90, and 2 times 90 is 180. We subtract, and we are left with 3. At this point, we have, oh, I see what I was doing. Stephanie, you're recording. I have Stephanie Peterson recording, so I just realized I'd made a mistake on the board earlier with this problem. We're making groups of 2, and we have 3 left. So I know that I can make one more group, and 2 times 1 is 2. Subtract, I'm running out of room, and we would have 1 left. You cannot make another group of 2 with 1, so then that ultimately is going to be our remainder. Now, the way they find the final answer is they are going to add up their partial quotients. 2,191, remainder 1. So that will be our final answer. And normally I wouldn't have had this written here, so we could have done that down there. But when they use this method, these numbers can be anything that the kids are able to work out mentally. So when they're doing this method, it's easier for students for 2 reasons. One, because they can use numbers that they can compute mentally. It's mental math. It's not something they're going to have to work out on paper. It's also problems that are really easy to have memorized. You don't have to do a lot of work to get the answer. Also, because when you use the standard algorithm, every step that you do has to be perfect. You have to have it memorized. If you make any mistakes throughout the entire problem is going to be wrong. This way, students can choose the numbers that they're going to use, and they can make the problem their own. They can make it easier for themselves. And I'm going to show you what I mean, because I'm going to do the same problem, and I'm going to change the numbers that I'm going to use to show you how they can still get the correct answer even when using different numbers. So some students, most of them all know at this point to start out with 1,000 or 100 or whatnot. And at this point in the year, the majority of them no longer have to write this down. I know that a lot of people are concerned with the new way that we teach certain standards in math. They think that it's more work, or they think they're having to write more. And when somebody's modeling how to do it, we are writing everything out so you will be able to see what we're thinking. But the students don't have to write this. And most of them, once they understand this method, they no longer have to do this anymore. So I'm just going to start out with 2 times 1,000 is 2,000, and we're just going to start there. Because it would not matter if I start here or if I start with 2,000. The only difference is my problem is going to be longer. But that's fine. Okay. And then we have 3, 8, 3, 2. So we're going to have an extra step now. Most of the kids at this point would probably do 1,000 again, because they know that 2 times 1,000 is 2,000, and they're trying to get rid of 2,000. And it still brings them back to the same point. See, at this point we were at 383, and we're still at 383 subtracting. We just have one case where the student knew to go ahead and jump to 2,000, and this student decided to do 1,000 2 times. It really doesn't matter. At this point, a student might say 2 times, like I said earlier, the 150 is 300, and they may choose to do 150, take away 300, because again, division is the same thing as repeated subtraction. And we are now at 83. At this point, the student would, again, did I do that right? I'm confusing myself.
Yeah.
Okay, so at this point, the students may say to themselves, okay, I know that 2 times 20, or 2 times, let's do 40. 2 times 40 is 80. And they're going to be able to get rid of a lot of it by choosing 40 as their next step. And now we're back down to having one group with one left over. So when they add this up, they're going to have the 2,000 plus the 150 plus the 40 plus the 1. And sometimes they have to line it up to add it up, and then sometimes the numbers are just easy and they can see it. It really just depends on the kid. We've got the same quotient in the end. These were our partial quotients. And we add them all up to get our final answer, 2,191. And then we have to make sure we bring in our remainder, which is 1. So you can see that this method could end up being really, really long if the students have not learned how to mentally pick the best number, or it could be short, and the better they get at it, the shorter the problems are. Whereas with standard algorithm, it's a set amount of work every single time, and there's absolutely no room to make a mistake, which is hard when you're a 9, 10-year-old child trying to do a problem where you literally can make no mistakes. This method and this strategy is going to allow for them to use numbers that they understand, that they can work with. I know it's hard when you have your child bringing home homework that's completely different than the way you learned it, but I would be glad if anyone wants me to show them anything further with this, or if you want to come in, I'll be glad to sit with you and help you understand it. But I will say that the majority of parents, once I've shown them this method, they even say that they think it's easier. And I'll be honest, when I started teaching this, the first time I saw it, I was just mind blown, because guys, I totally relate. I learned it exactly the way that you learned it. And that's the way that made sense to me. This literally made no sense to me when I started teaching it. But after I understood it, this is how I would divide now. If I didn't have a calculator and I had to do it paper pencil, this is the strategy I would use, because ultimately, once you understand it, it is definitely quicker than the way we learned it. So there you go, guys. And if anybody has any questions or you have any requests for anything that you want me to show you, I'll be glad to help you. Thanks.